Okay, let's dive right into this. Welcome to The Explainer. Today, we're unpacking a truly revolutionary deep tech pitch deck. We're looking at a proposal that attempts to totally bridge the gap between mind-bending theoretical physics and, well, highly grounded venture capital. The core premise here? Generating macroscopic topological gradients to fundamentally change exactly how we propel objects through space. It's called the topological vacuum gradient drive, and honestly, the promise is right there in the title: bending space, not burning fuel.
And that brings us to a massive, fundamental question. Really, the cold open hook of this entire pitch. How do we actually move in space without burning fuel? Because right now, this is literally the ultimate physical barrier to deep space transit. Every single rocket we launch today is essentially just a giant controlled chemical bomb, right? We are strictly bound by the limits of traditional physics and reactionary mass.
So to understand exactly how they plan to shatter that barrier, here's our roadmap for today. Number 1, the trap. 2, bending space with lasers. 3, extreme engineering and the ask. 4, the commercial plan B. And 5, the strategic go-to-market roadmap. All right, section 1, the trap, the limits of current physics. Let's look at the fundamental problem holding humanity back. The pitch sets up this really stark contrast. Under current physics, humanity is completely trapped by Newton's third law. Right? For every action, there's an equal and opposite reaction. To move a massive object, we literally have to burn a massive amount of chemical fuel. And worse, when we want to test new physics, stuff like vacuum manipulation or artificial gravity, we're stuck building billion-dollar city-sized infrastructure like the Large Hadron Collider. But look at the proposed new paradigm here. This deck is pitching a reactionless drive. It proposes manipulating the vacuum lattice directly using a laboratory-sized top-top setup. I mean, that is an absolute paradigm shift. It promises to take quantum vacuum theories straight out of the multi-billion-dollar particle accelerator and put them right onto a lab bench to do real, macroscopic mechanical work. Section 2. Bending space with lasers, the magic made real. So, how on earth do they plan to actually do this?
Well, the pitch relies on something called the pinch effect. And yeah, I know that sounds like some heavy sci-fi jargon, but let's unpack it simply. The working model here entirely rejects the idea of an empty vacuum. Instead, it defines the vacuum as a rigid lattice of nodes. Specifically, it talks about manipulating 55-node vacuum clusters. These are known as Macroscopic. Think of it kind of like taking a giant sponge and just squeezing it in your hand. By creating a macroscopic pinch effect, the system acts like a compressive vice on this vacuum lattice. And that squeezing action, that generates a localized field of fictitious gravity. So ultimately, you're bypassing reactionary mass entirely by just generating an artificial spatial density gradient.
Let's move to and see how this builds into an actual physical device. The optical layout is, surprisingly, remarkably straightforward. Step 1. You fire an incredibly powerful 800 gigawatt solid-state femtosecond laser. Step 2. That flat laser beam passes through a vortex phase plate, which basically imprints a helical phase front on it, and then it goes through these conical optics called an axicon. And finally, step 3. A Fourier lens transforms that light into a perfectly stable 60mm non-diffracting plasma ring.
Now, we got to talk about the sheer scale of the power involved here, because it is truly mind-bending. 800 gigawatts. Just to put that into perspective for a second, that is roughly equivalent to the entire electrical generation capacity of the United States. And they are concentrating all of that into a razor-sharp 39-micron hollow plasma wall for just a fraction of a second. At that extreme energy density, the local intensity completely surpasses the atmospheric ionization threshold. That's what creates the massive ponderomotive force you need to compress the vacuum lattice.
But you're probably wondering, right? Wouldn't 800 gigawatts just instantly vaporize the equipment? Well, the pitch addresses this physical bottleneck head-on, the B integral, which, think of it as basically an optical speed limit that measures nonlinear phase accumulation. That is strictly managed at 0.93 radians. Because they stay well below the threshold, the optics are entirely safe from self-focusing and shattering. So they've actually run the math to ensure the machinery completely survives the magic.
Section 3. Extreme engineering and the ask, the pragmatism. This is where the pitch really pivots from mind-blowing astrophysics to very grounded pragmatic business reality. The project's lead architect, Peter Kajovsky, sums it up perfectly. He says, no sci-fi, just extreme engineering applied to 55-node vacuum clusters. And honestly, that is a massive de-risking statement for any investor. The pitch emphasizes that 100% of the system is designed using commercial off-the-shelf or COTS components.
We're talking about really high-end but existing hardware from industry leaders. They aren't trying to invent brand new, impossible metamaterials from scratch. They are just brilliantly combining existing top-tier engineering to unlock brand new physics.
And this brilliantly illustrates exactly why it's such a highly capital-efficient financial ask. They literally only need a €1 million investment for an 18-month proof of concept. Think about that. In the aerospace world, where a single traditional rocket engine costs tens of millions, $1 million is absolute pennies. A full 75% of that goes directly to the laser core, securing a massive 800-gigawatt system with a strict manufacturer guarantee. 10% goes to mechatronics and FPGA, 5% to optics, and 10% to assembly and IP. Because they are buying commercial off-the-shelf hardware, the investment goes entirely into hard, tangible assets, rather than just endless theoretical R&D.
Section 4. The commercial plan B, the safety net. Because, what if the vacuum physics takes years to fully prove out? That is always the elephant in the room for deep tech investors.
Well, to keep a plasma ring stable at 800 gigawatts, you need unprecedented active control. So the team designed a dedicated FPGA-based system that operates at a blazing 422 microseconds. For context, that is literally hundreds of times faster than the blink of a human eye. It analyzes the laser's purity in real time and corrects the beam via piezo mirrors, safely staying below the strict hardware limit.
And here's the Trojan horse twist of the entire pitch. Even if the whole space travel application gets delayed, this sub-millisecond closed-loop stabilization IP, it's immediately commercializable today. A control loop this incredibly fast is highly disruptive for massive existing markets. They could spin this off directly into ophthalmology for better laser eye surgery, into the semiconductor industry for extreme UV lithography, or even precision micromachining. It's just a brilliant safety net that heavily hedges the investor's risk by targeting immediate multi-billion-dollar markets while the deep space vacuum research continues in the background.
Section 5, Strategic Go-to-Market Roadmap. So how do they actually execute all of this?
Over the course of 18 months, that €1 million investment translates from a paper concept into physical reality. Months 1 through 9 are focused entirely on proof of concept assembly, getting the core secured, aligning the table, and actually firing that very first stable plasma ring. Months 10 to 14 then shift into IP registration for their control loop and actually measuring the generated topological force. Then from month 15 onward, they target Series A funding for propulsion scaling, or they just begin licensing out that stabilization IP. It's a really smart two-pitch deck strategy. Validate the complex science with academic partners while securing capital from deep tech venture capitalists.
So the crucial point is this. The ultimate vision here is demonstrating fictitious gravity to displace matter completely without reaction mass or inertial g-forces. If they pull this off, it doesn't just improve aerospace propulsion a little bit. It completely disrupts a long-term addressable market worth over $350 billion. It would literally change satellite station keeping and deep space transit forever.
I want to leave you with this final thought. If we can command the quantum vacuum using off-the-shelf lasers today, what other impossible barriers out there are actually just an engineering problem waiting to be solved? This pitch is a masterclass in grounding the absolute bleeding edge of theoretical physics with rigorous, pragmatic engineering and a brilliant commercial safety net. It really makes you realize that the future of deep space might not rely on burning massive chemical rockets at all, but instead on how precisely we can shape a beam of light. Thank you so much for joining me on this explainer, and definitely keep your eyes on the deep tech horizon.